an amazing one and in high demand for teachers and for schools as well. Just a small bracket to tell you that by Thursday, once I finish my 4 days of webinars, I'll be preparing hopefully the certification, and I will be sending them for all those who filled the attendance sheet that I'll be sending by the end of the session, the link in order to fill it. So please stay tuned till the end of this session that I'll be working hard to finish it in just 1 hour. So it could be helpful for you. I will start my presentation by sending you the link for our platform, excuse me, which is www.01.education. For those who are not aware of it, for the teachers who are using our curriculum, because this session is open for everyone. So for the teachers who are using our curriculum, if you don't have an account on this platform, please do create an account in order to get access to all the books and the resources. I'll be sending you right now the link on the platform for the YouTube where you can watch. It's a guide to tell you how to get into the platform and to create your account as teacher. This is one. Second, for the students, they have right to create also their account. I will send you on the chat also another link also for YouTube that you can distribute for your students in order to create their account. But here, teachers, please be aware that in order for students to get into the platform, they have to get their ticket number. And the ticket number I have to provide you. So every school that are using right-click or 01, you will be sending me by email or WhatsApp the number of students you have. In reverse, I will send you an Excel sheet that covers the ticket numbers that you will be distributing for your students. So, and now I'll be sharing my PowerPoint. So please tell me also if you can, sorry. All right. So just also give me a sign in the chat if you can see my PowerPoint. All right, great. So till now I sent you 3 links: the platform, the video for the teachers, and the video for the students. So even if you have an account, you have to activate it at the beginning of this academic year. Today we are going to explore Arduino, and then how to implement it in our curriculum and how important it is to have it in our curriculum and in our schools. This is first. I'd like to inform you that the updated version of right-click, it's now called 01. And in the collection 01 from grade KG till grade 12, which is 2023, there is a chapter starting from grade 7 that covers Arduino. It's very important to know that this is one of the chapters challenging chapters that you have to concentrate on for this year in order to move your schools from one place to another. This is one. In case you are still using right click, please do contact me in order to provide you the additional chapters of Arduino and the robotics that we did yesterday, the MBO2, in order to get the maximum profit from this curriculum for this year, waiting for next year to move to 01. So I'll start my presentation by asking a question, which is why Arduino in the curriculum? And like yesterday, if you remember well, that the robotics as content, educational content, is divided into three main parts. If you remember, I will send again, Mrs. Abir, all the links just in a while. So yesterday we said that for the robotics, in order to teach robotics, we have to split the process into three main sections. The first section is a general overview to convince students why they have to learn robotics in the curriculum, to have a general overview of the content. It's not allowed for the students not to be able to answer basic questions regarding the robotic science. So this is a very important part. Me as a teacher, I really focus on this part because it's the most important. Why? Because if your students will be asked by his parents, his friends, by expert, by professional, by the academic directors at your school regarding this topic, he has to get clear answer. It's very important. It's very critical, and it's very embarrassing for you and for the students not to get answer for this. Else the academic director or the principal or any person will say that the process is not correct. This is one. Second, the second part for robotics, it was like to program the robot, to master the coding skill for this robot. And third part, it's to build and to modify the structure of the robot in order to add additional functionalities for this. Same for Arduino. I mean, Arduino, it's based on three sections. The first section is to understand this science of microcontrollers. Why Arduino? Why microbit for tomorrow? Why? Then after, understand the component of Arduino and the input-output devices, to understand how to build circuits virtually. And the third part will be how to move to what we call projects in Arduino. And you must know from my own experience and from the experience maybe that you have with Arduino, for those who worked with Arduino, that for lower grades, I mean for grade 7, 8, 9, it's a little bit critical to make students understand the concept, the content, and to make the project by hardware wiring. It's like impossible to make those three steps at the same time. That's why in the new curriculum of our 01, we've updated and we've added the Arduino for grade 7, 8, 9 virtually by simulation by using Tinkercad. So we are mostly sure that by grade 9, students will understand and will master the first two main parts of the Arduino science, which are the general overview, understanding the concept, and then how to program simple circuit by simulation. Arriving to grade 10, so they can handle the hardware. And this is not to say that if you have a small group of students and you want to share with them how to create Arduino projects by hardware, you can do them and you can get our support 100%. No worry for that. All right. So let us be clear. Also, Arduino, it's divided into 3 main parts. Today, we are going to focus on part 1 and on part 2. And by the end of this session, I'll be sending you this PowerPoint in order to share it or to explore it with your students for the maximum. So once you got, I was saying that before starting this webinar, a major question should be asked, the why. Why Arduino in the curriculum? Once you got the answer to the why, you can proceed in a secure and confident way to explain for students the Arduino chapter. The major obstacles for ICT teacher to teach Arduino is to get a solid background in electronics and programming in order to create projects. And I know from myself that I'm a computer scientist. I'm not an electronic man. So I struggle somewhere by explaining for students some electronics and electricity concept. Don't be afraid of that. We as teacher, we have this power to say, I don't know. You have to ask your physics or your electronics teacher in order to get more information. What we focus on and we concentrate on. I will be sharing the PowerPoint. I will be sending you the link here, but not now, by the end of this presentation, in order to be concentrated with me on this PowerPoint. So we as ICT teachers, we are going to focus on the concept of the word of Arduino, plus what we call the skills in programming and in building circuits, but some questions regarding the electronics and the electricity are dedicated and are reserved for the science teacher. So that's why hardware and coding concept will be developed during this webinar. Level 1, because we have 2 levels in Arduino as a presentation, we cannot do it in the same during the same day. So level 1 skills will be covered during this session. Level 2 will be on a later stage, and then we will start this webinar by introducing the word of microcontrollers in order to be able to find or to conclude the answer to the why Arduino in the curriculum. It's a real message that we have to answer to. To get answer to the why, we should define the skills to be offered to our students reaching grade 12, as I said yesterday. And we all know that main skills that should be developed in ICT and robotics in order to make students understand tomorrow's world are coding, machine learning, artificial intelligence, and IoT. And 01 and right click offers those skills in an educational curriculum tested for more than 22 years. We have to know that, especially in Saudi Arabia, we talk too much and frequently about artificial intelligence, IoT, and we know as teachers that in order to reach artificial intelligence, IoT, machine learning, basic skills should be given to students. We cannot click the switch in order to start teaching artificial intelligence like this. We have to spread, to give our students main concept in algorithm, as I said yesterday, in coding, in robotics, microcontrollers, and other skills in order to reach this point. And I promise you that very soon we will be delivering an additional curriculum that supports IoT and artificial intelligence deeply with concepts based on what we okay, Mr. Muhi Abdesalam, I will take note. Excuse me, I'm grade 5. Sorry, excuse me. The moment I finish my presentation, I'll give you access. Excuse me, but I'm late because I have too much tasks I did today. You are right. Excuse me. So microcontrollers, by definition, it's divided into two words, and this is what you have to say to your students, that microcontroller is divided into two words: micro, which means small, and controller, which means it controls something. And a microcontroller is used in all electronic devices that we use every day. This is what you have to say and to inform your students in order to convince them that microcontrollers, Arduino, microbit is essential, is very important for them to understand and to control, since all the objects, electronic objects around us are using microcontroller. And a microcontroller is used in an electronic device to control it for a better functioning. Example, when the door of the fridge is opened, the light will turn on. It's a simple, basic example of what a microcontroller can do in order to turn on and off a light. A microcontroller used in an electronic device is programmed only by manufacturer. The user can never program it. I mean, in the fridge, washing machine, any kind of microcontrollers, we don't have this option to change the program inside. But later on, with IoT, it's doable, and our students must be aware of that. IoT, by definition, is the future technology that will link every single device to the internet. IoT will allow us to control, by using an application, those devices remotely, in medicine, in industry, in services, in every single real sector that are around us. So we are going to be controlled by those IoT. So here, as you can see, IoT enable shops, airport station, mobile devices, edge IoT devices, data center, and so on and so on. This presentation could be helpful for you in order to share it with your student at the beginning of the Arduino chapter. IoT is the solution. IoT will lead us to the world with less pollution, less consumption of natural resources and electricity, better medical life, better production in factories and agriculture, less traffic, etc. So since all those devices will be connected to electronic devices, and we can analyze data in every segment that we are using. Microcontrollers and IoT, it's possible to reach the IoT world. It's impossible, excuse me, it's impossible. Can I open in full screen? Yes. Sorry, can you see my can you see my full screen? No, I can't open anymore. I don't know why I cannot open my my chat now in full screen. Just 1 second. Okay, no problem. So it's impossible to reach the IoT world without understanding the components of a microcontroller and how it functions. That's why the introduction for students to the world of microcontrollers is a must. Microcontrollers and IoT, as I said before, IoT as a solution is not possible to reach without the integration of microcontrollers in the devices to be connected. And here, many examples could be given to your students. For example, the cars, if they are connected to IoT, they can inform the manufacturer of a possible failure in some devices, so we can prevent and we can accelerate our production in order to correct this error in the near future. The conclusion is that after this brief introduction, it's now possible to answer why it's a must for students to learn how to program and work with a microcontroller. The need. So what we need for that, in order to create an educational circuit to understand how to reach the IoT world, you need electronic devices such as sensors, motors, pump, screen, LED, push button, etc. So teachers should keep in mind that, and this is very important to convince students for using microcontrollers for additional and advanced projects, that input-output devices that are connected directly to the computer are limited to the keyboard, mouse, scanner, microphone, screen, printer, speakers, projector, that it is impossible to connect directly a sensor, a LED, a motor, a push button, or a pump to a computer. That's why we are in need as electronic board for a microcontroller that will play the role of linking the computer to all the electronic devices that could not be linked directly. So the Arduino board or the any other microcontroller like the microbit, the Raspberry Pi, and other are used because we cannot directly connect all the other sensors, motors, pumps, and LEDs directly to the computer. So it will play the role of a bridge between the computer and the devices that are around us. It will be the brain that connects all this. The brands, for educational purposes, many brands are available on the market. Only two major brands are leading the market. We are talking about Arduino. The Italian board is dedicated for upper grades starting from grade 7, 8. The microbit, the British board, created by the BBC, is dedicated for lower grades starting from grade 3, 4. And microcontrollers, what are the difference between, let's say, Arduino and the microbit? Arduino does not contain any input-output device, so it will be hard for lower grades who don't have any electronic background to build a circuit using Arduino. That's why we are using, and tomorrow we will be explaining the features of the microbit version 2. So the microbit is loaded with a display LED screen, 25 LEDs, 2 push buttons, 3 sensors. This will facilitate the learning process for kids in lower grades in order to be prepared for the higher grades. Some example before moving to practice. Let's say for the Arduino, we can create a parking gate. We can create a plant irrigation with Arduino using the soil moisture sensor. We can create a project to detect objects and distance. We can create projects to test and humidity and temperature. So now we will be moving to practice. I believe that this introduction for like 20 minutes will give you all the support you need in order to start this simulation with your students as a general knowledge about the world of microcontrollers, why we use and what are the microcontrollers used. Now we will be moving directly to the hardware and the software. So in order to manipulate Arduino, students must be introduced to the hardware used to build a circuit and the software needed to create a program. So the hardware, we have, first of all, the board, which is essential for any project. It is considered as the brain of our circuit. It is used to link the input and output devices to the computer to perform a specific task. The breadboard that it's on your left on the screen, it's used essentially for any project to extend the connection of digital ports since they are limited on the Arduino board. So we can compare the breadboard to the electric socket where we can plug many wire for electricity to charge my laptop, my phone, my iPad, and so on. We are in need for the LEDs, considered as the output device, and it's a must to manipulate, to start learning the Arduino language, the resistors, the motors, the buzzer, the ultrasonic sensor, the temperature and the humidity sensor. And you have to know that we have like a pack for 37 sensors for more creativity. You can find them anywhere on any online platform. Now, let's move to the software. And here we have two options for the software. And by visiting our digital platform 01.education, you will be finding the two softwares directly to download, which are from the official website, which is the Arduino software, where you have to code in language C++. No simulator is available. Students must connect to an Arduino board to test their project. And this is a little bit hard for students in middle grades. I mean, in grade 7, 8, and 9. That's why the solution during Corona was built by Tinkercad, Autodesk, and this is what we are going to explore today with you. So the Arduino software is a must to write the program in order to download it on the hardware, the Arduino microcontroller as a hardware. Another solution, which is the tinkercad.com, and here I invite every one of you to create an account on Tinkercad, because it is a must for the for you as teacher and for the students in order to work and to move forward to develop skills in 3D designs, in circuits, in code blocks for this free platform. So here in the Tinkercad, there is an error. There is a simulator that we are going to see. So you have to log in on tinkercad.com, select personal account, and then choose one of the three proposed options. If you have a Google account or any email you have, you can sign in to get a simple account on Tinkercad. The advantage of having an account is that all the projects developed will be kept, will be saved on this account in order to get more information for later on. So once you enter the main website, okay, or the main page of Tinkercad, you go on new and you select circuit, and then here I will show you, not in I will stop in a while the PowerPoint presentation in order to move forward to Tinkercad Live and to show you how simple we can create our circuits. And then after, I will show you our curriculum grade to have a look at grade 7, 8, 9, as a first contact with. So examine the block generated by default. So once you launch Tinkercad, by default, you will have 4 blocks in the forever loop. Set built-in LED to high, wait 1 second, set it to low, and then wait 1 second. The built-in LED, you have to know that it's the LED on the board, it's circled by a red circle. So, and there is the letter L to indicate that this is a LED, and it's connected by default to port number 13. We'll explain that this in a while. So, and once you want to move from block to C++, all you have to do is to click on code, to select blocks and text, and automatically the block generated by the Tinkercad will be generated as C++ code. All you have to do is to select, to copy paste, and to go to the Arduino software in order to download it if you have a hardware implemented. So the first project that you have to build is to connect a LED with a resistor, and then to move it to the software Arduino in order to simulate it on the hardware or virtually on Tinkercad. So here we have the piezo, but just to see what I still have in order to move to the live workshop. So I believe it's done. Great. So now I'll be just 1 second. So now I'll be moving to please, can you tell me if you can see also my can you see my Tinkercad page, please? Can you give me a sign on okay, great. Excellent. Excellent. So so as you can see, I'm on my page. From time to time, Tinkercad change a little bit the design. It's not a problem. So here you can see the different projects I've did previously. So all you have to do, once your students are in the digital platform tinkercad.com, you can go to create and to choose between 3D design, circuit, and code block, which is which are the 3 parts of this platform. And the good news is that in our update on with 01, we are the first publisher to introduce the 3 blocks of Tinkercad in our curriculum in order to offer our students those. So I'll click directly to circuit, and this is what you have to do with your students as a first step starting grade 7 for this year. So you will see that on your left, on your right, sorry, you have what we call the basic components, all components. As a starter, you have Arduino microbit or circuit assembly. I will stay on the basic, okay, and you will see that I have the resistor, the LED, the push button, the potentiometer, the microbit, the breadboard, the Arduino, and other features like the LDR, the soil moisture, the piezo, ultrasonic. So those are the let's say the tools or the sensors that you are going to use. So the first thing I have to do is to move an Arduino board. And as teacher, what you have to do is to explain the components of the Arduino board. And I will start directly by telling you that on this Arduino board, I have the 5-volt pin, the 3.3 volt pin. I have 3 grounds, which are here, 2 and 1 up. I have 14 digital pins from 0 till 13 that can provide the plus to connect for a circuit. And I have, and they are called the digital pins. And down on my right, I have the analog pin A0, A1 in order to read analog information like the distance, the temperature, and other figures. So, of course, I have the reset button, the USB port in order to connect my board to the computer in order to turn it on, and in order to download my program. And in case I want a standalone project, I mean, if I want to attach to my board a 9-volt battery, I have to connect it here. So as a first step, what I can do, I can move a LED, and the cathode, which is the negative leg, and the anode, which is the positive leg. You can see that the anode, it's like a little bit curved because it's the longer lead of the pin. So I can move it here. I can connect it to the ground, and then I can connect the anode to digital pin 13. And if I go to the code, by default, I have my code built in for the built-in LED. If I click on the run, you will see that the 2 LEDs will start blinking, which is the LED on the board and the LED that I've added, with a exclamation mark, a warning mark that the LED will be burned because it has to be protected by a resistor. And it shows that the resistor that I have to implement, it's like 220 ohm. So what I will do now, I will stop the simulation. I will remove, I will remove the leg here, excuse me, and I will connect it to the pin 11. And then I have to go to my program. I remove all the blocks, and instead I will select set pin, and I will choose pin number 11. From control, I have to go to wait 1 second, and I can duplicate my blocks in order to make it low. And here I can change 0.2 by 0.2. And once I click on the start simulation, my LED will start blinking fast. And after that, you will be showing your students that I have to move a resistor. I will make it horizontal. I will change the value to 220 ohms, and then I will connect my LED to the resistor, and the resistor to the digital pin 11, I think. I go to my code, I will launch it again, and here you can see that my warning message is not anymore on the screen because my LED is protected. This is a simple project that you have to start with your students. I'll be showing you now I'll be showing you now just 1 second. All right. So here you can see all right. So here you can see 2 pages. All right. All right. So here you can see the chapter of Tinkercad or Arduino for the grade 7, and as a first lesson, it's an introduction for the devices of today, IoT, the elements of smart objects, the microcontroller, educational microcontroller, projects with microcontroller, and the component of the Arduino board. You can see that my presentation is aligned with the content of the book, because I'm a teacher like you, and I tried this method with my students, and this is the result of what I got from my students in order to make them understand the Arduino world in a simple word. So here, lesson 2, discovering the Tinkercad platform. On the second page, exploring the Arduino pins, as I did before, as I showed you, exploring the LED, the anode, and the cathode, and the same example as I gave it to you in a while. So you can see that it's really aligned, and you will feel comfortable with this curriculum, since information are well explained and well given. In the third lesson, I'll be exploring the breadboard that I did not showed you till now. And then with the breadboard, I have this capacity to add 2 LEDs and more, add a buzzer, and control them more and more. So imagine your students, as a result for this chapter, that they will be controlling LEDs, buzzer in a educational way, and this will prepare them to explore more and more, to go on the internet, to watch YouTube video, in order, if they want to buy extra hardware as Arduino and to start playing with them at home, it will be very beneficial for them. And even if they have to participate to local competition, or even if they will participate to what we call the science fair or technology day, tech days at your school, they are able to create projects and to show the owners of the school, the academic directors, all the community of the school, parents, friends, and so on. So here, as you can see, even we explore the fading frequency of blinking by including variables, which is very important to master with Arduino. And as a result, the variable for each LED, so we can make this mix, and you can see how clear this lesson is in terms of presentation and in terms of progression of the content. And we will end grade 7 by integrating the LED. So we are not asking from students too much to do or too much to give. It's enough for them in grade 7 to understand those concepts, and believe me, in grade 8, they will be moving forward with extra hardware, and you will be preparing them for a better understanding for this chapter, microcontrollers. We are talking about 6 lessons. I mean, like 1 month and a half, which is very, very logic. So I will be back to explore my breadboard. So now it's time to stop the simulation, to hide the code, and to take the breadboard. And mastering and understanding the concept of a microcontroller is a must, because we cannot create additional or advanced project. Can you please turn off your cameras لو سمحتوا? So once we understand the content of the breadboard, so we will be moving for additional projects. So the breadboard, as you can see, it's divided into 4 main sections. The first section is the top section and the bottom section, and in the middle you have 2 sections where the holes are connected even horizontally or vertically. I mean, for the upper section and for the lower sections, the dots are connected horizontally. For the inner sections, this one or this one, by moving the mouse without clicking, you can see that all the dots are connected. I mean, I will delete my LED, and this is what you are asked to do with your students. I will take a wire from the ground and I will connect it to this this hole. So now all those holes, all those pins are connected to ground. Then I will take a LED, I will take another LED, and as simple, I will take a wire, I will connect it to the cathode, another wire, I will connect it to cathode, to a cathode. And this is it. If I want to add 10 other LEDs, I can do, and I can take from the ground pin as many as I want. Now I will move, I will turn it vertically, horizontally, I will duplicate and I will put it, I have to move maybe a little bit this one. Okay. And then I will place another one here. And from pin 6, I will take and I will connect to the same column of the resistor. And for grade, for pin 3, let's say, to this pin. And this is it. My circuit is done. So imagine now that this circuit that I did virtually without any effort from you or the students as hardware, it's not embarrassing for you and for the students. My circuit is done. The logic is here. The students will understand that one day, if you will give them wires, if you will give them a breadboard and LEDs and resistor, they have to copy this circuit on the hardware. Amazing. Believe me, amazing. I've tried it with my students for many times. You cannot imagine, once you show the circuit on the big screen, they copy it, and then you ask them to modify it in order to make sure that they understand this, this concept. So now I open my code, and as simple, my LEDs are on grade 6, on pin 6 and 3. I change here to 3 and 3. I click on run, and you will see that only one LED is blinking. I duplicate my blocks and I set the pin to 6 and to 6. And instead of 0.2, I will put, let's say, 1. And here, start simulating. So you can see that there is a difference of time between the blinking between LED connected to 6 and LED connected to 3. So now many scenarios could be given to continue this exploration. So maybe you can ask your students to change the script in order to make the two LEDs blinking together on and off. So they have to change the order of the blocks in the script. And look here, once I click on the blocks, I can switch to blocks and text, and amazing. Believe me, it's amazing. So all you have to do is to copy the blocks and to go to the Arduino software and to connect it to the board and to download. Here, I forget to tell you something very, very important. Please do not do this error or mistake. Students in Arduino are not supposed to memorize the code as in small basic, Python, or any other coding language, because all the scripts exist online. All you have to focus on is the logic of building the circuit and how to change the code, not how to write it from scratch. And as you can see, every Arduino program as C++, it's divided into two main parts. You have the setup function or the setup loop, and sorry, the setup function and the loop function that will be repeating the functions many times. Okay, I have like 7 minutes, so I can continue by adding the push button. I have many projects I can do, but I'd like to show you, let's say, the other chapter of Arduino in grade 8 to tell you how coherent and how simple moving from one chapter to another in order to make you confident of this. So here we are in grade 8. Just 1 second. Okay, so here in grade 8, you can see that the first lesson is the brain is an electronic device. List 5 electronic devices you use every day. So there is many questions that are asked to make sure that students did understand from last year the concept of microcontrollers and objects in every object they are using, the definition of the microcontroller, educational microcontroller, the components of the Arduino, and then serve the internet, and list 3 projects that you can create with the Arduino board to create a smart house. Second lesson, we start by the output components and the input components. And here we explore what we have as output and input components. As I have a question, what about the students who didn't study? Hey, it's an amazing, Mr. Muhammad, it's an amazing question. So if they don't have previous experience, you can go through the digital platform, open book grade 7, and explore with them the basics of Arduino. So you have to simulate it somewhere in a quick way by focusing on the PowerPoint that I will be sending you right now, and on the first chapter in grade 7, like you will be doing 2 to 3 lessons, and then after you will be moving in grade 8. So even if they don't have previous experience, 7, 8, 9, the introduction will be almost the same. All right. So here we will be exploring the output devices as the LED, the buzzer, the water pump, the servo motor, the DC motor, the screen. As input device, you will be exploring the push button, the LDR, the temperature sensor, ultrasonic sensor, soil moisture sensor, and other devices. And then we will be exploring the link between the Arduino and the breadboard. And a blinking project is asked at the end of the second lesson. The third lesson will be how to control the output information using variables, okay, by controlling the speed of the LED, reversing the speed of the blinking. So those are projects to explore more and more and to make sure that students perform those skills in a correct way. We move directly to the resistor, and then after the fading project, and then after the what we call the serial monitor, which is very, very important to master, since the Arduino board does not include a screen in order to show information. So the serial monitor is your solution in order to explain or to show the data that we are reading from any input device. Then after, we'll start by STEAM projects like the input devices, like the LDR, which is to control the quantity of light, intensity of light, in order to make the LED turn on and off. And as you can see on page 73, the serial monitor can show us the amount or the value of the light read by the LDR in order to control the blinking or the turning on and off. In lesson 6, we are controlling the a robotics arm in order to perform mechanical action. And in lesson 7, we are controlling the push button. And here, all those skills are skills previously given to grade 10, 11, 12. So imagine now, we started those skills in grade 7 in order to let your students, once reach grade 9, 10, 11, and 12, to master easily those skills and to start working on the hardware, which is a skill that they have to master for STEAM project and to understand more and more IoT, artificial intelligence, and other. And we end lesson 8, I mean like 8 periods, like 2 months, by controlling the push button, the servo motor and the LED with a push button. They are asked to create this circuit, and then after to control it, once I click on the push button, I have to turn on the LED and to make the servo motor work, turn on and off. So I believe that first of all, I'm very happy to see that there is 71 participants or 70 participants for this webinar. I hope that I give you an added value for what we've did previously, because I know very well that we did last year maybe Arduino, but we have to rethink, and especially that now Arduino is built in our curriculum 01 starting from grade 7. I'll start sending, first of all, the link to the PowerPoint. So please be ready on your chat, the link to the PowerPoint that I shared. This is it. So this is the Arduino PowerPoint, first. Second, the video for teachers to create an account on 01.education. This is the video for you teachers. The video for the students. Excuse me. I'm sending to Abir only. Excuse me. So copy link. This is the link for the PowerPoint. The second link, excuse me. The second link is the link for you as teachers in order to create your account. This link is for the students to distribute in order to get their account. But here, remember, you have to ask me for ticket number for the students. The third link is to fill the form, which is very important, for the Google form for your attendance in order to get the certification and to prove me that you were here in order to send you the certificate of attendance. Okay? And I remind you that on the digital platform, we have a detailed teacher guide for all the lessons that we are exploring in the book.